All right, so what we want to do, we've talked about proportions just mathematically, but we want to start looking at using proportions to solve practical problems. And the first set that will look like are proportions with what are called ratios. All right, and so we're going to use what's called a ratio to solve some proportion problems or some more practical problems. And the next video has to deal with unit conversions, which is just a special case of doing this. All right, and so in math, we often use this word ratio, and what a ratio is by definition, it's a comparison of like quantities. Okay, and I'll explain what I mean by that word like in just a second. So let me just give you an example here, like inches and miles, which will be our first, it'll be embedded in our first example. Okay, so the thing is inches and miles are two different ways to measure length. Okay, so these both measure lengths, and so those are like quantities. They measure the same kind of thing, just like seconds and hours or something like that. Those are like quantities for time. They're just different units. Okay, now they're usually expressed with a colon, sorry. Not always though, because there's another way to express them. All right, and so you might see something like 2 colon 5, and the way that thing reads as 225. Now there's usually, this is kind of hard to follow probably right now because there's usually some units attached to it. So 2 inches, 5 miles, like that. And what that does is that gives you a way to relate those two numbers. Okay. Now, one important thing about ratios, and that the way we'll use this, is we can always write a ratio as a fraction, as the first number over the second number. Okay, and that's where the proportions are going to come into play because now we have a fraction. Okay, so let's look at an example now. All right. And so let's look at this example right here. So we have a map, and there's on a map there's something called the scale, and that allows you to measure distances on the map and then convert them into actual distances. So you have an idea about how far you need to travel. So that's the scale. And so the scale on a map says that 2 inches is equivalent to 5 miles. All right. Now we don't have a problem to solve yet. I'm just showing you the idea of this ratio. So whenever we whenever we say two things are equivalent in terms of measurements, we're talking about a ratio 2 inches to 5 miles. Now, you might want to be even a little bit more specific. This is 2 inches on the map is equivalent to 5 miles of actual distance, like that. All right. And so now what you want to do whenever you have units, you want to keep up with them. I'll show you places where we can drop them. Okay. But if we want to write that as a fraction, we would say 2 inches over 5 miles, like that. If you know abbreviations for these units too, you could use the abbreviations. But if you don't know the abbreviations, just write them out in words. Okay. Like that. And so we have that idea right there. And what we're going to do is we're going to use that fraction to be able to measure actual distances now. All right, so let's stick with this same example. So the scale on the map is 2 inches to 5 miles. And so we could say 2 inches on the map to 5 actual miles. Okay, and it just depends on how much you can remember or how much you're liable to forget about how much detail you want. You could just say 2 inches colon 5 miles if you can remember that the inches corresponds to the map and the miles corresponds to the actual distance. Okay, but that's up to you. All right, and what we'll see is once we do some math, we'll just use the 2 and the 5. Okay, so here's a question I can ask. Say I take the map and I measure the distance between two cities, and the distance on the map is 2.4 inches. And then I want to know how far apart are the cities actually apart. Okay, so now what you want to do, and these are actually pretty straightforward once you get used to them, but the key thing is to keep up with the order in your ratio. Okay, and so our given ratio is 2 inches to 5 miles. Okay, like that. All right, and so the form of our ratio is inches over miles. Okay, I'm going to use the abbreviation, but you could write them out too if you don't know the abbreviations for them. Okay, so we have 2 inches to 5 miles on that map. Okay, and now what we want the actual distance, and so we want the miles. Okay, and so what you can do is you can get a proportion based on the given ratio. Okay, like that. And so again, now whenever we actually do math, as long as you can keep up with what the units actually are, you don't necessarily need those units in there because they'll clutter things out. So 2 over 5. Okay, just make sure to keep in mind that this is inches over miles. Okay, and so just make sure to keep that in mind, because whenever I come over here, so what needs to go in the bottom are the miles, and what needs to go in the top are the inches. And we get this from any information we were given in the problem. What piece of information have we not used is that the distance on the map is 2.4 inches right here. So where would that 2.4 go? It would go in the numerator here. All right, and so there I have the 2.4, and see, I want the miles, so I could just put X right here. Okay, like that. If you wanted to be a little bit more descriptive, since these are miles, you might want to use M to remind yourself that those are actually miles. I think I'm going to stick with the miles right there. Okay, and so now we have a proportion. Hopefully you're getting used to proportions. We have a fraction equal to a fraction, and so I can take advantage of that shortcut and equate the cross products. All right, so the cross product in red there is 2 times M, and then the cross product in blue is 5 times 2.4. You probably want to do that on your calculator. I realize I don't have mine with me right here. So that's 12, like that. Okay, and so 2.4 times 5 is 12. And so then what do we do to isolate M? Well, we divide by 2, and so we get M is equal to 6. And so to answer this question, remember, we don't want to stop here. At the very least, you should include units. Okay, 6 miles. If you really want to answer very clearly, we would say the cities are 6 miles apart, or you might say the distance between the 2 cities is 6 miles. You might word things differently, but make sure, very important here, is not to just stop right here. Okay, that's the mathematical answer to the problem, but the answer to the actual problem is that the cities are 6 miles apart. Okay, now if you notice in that last example, the ratio wasn't given to us. We had to convert some wording to get that actual ratio. Some problems actually explicitly give you the ratio, so let's look at an example of that. Okay, so if you're unaware, weight is a reflection of how much gravity is acting on a person, and there's less gravity on the moon. And so this is a very expensive weight loss routine, but you could lose a lot of weight just by traveling to the moon. That's a little joke here, but let's look at the problem here. Okay, the ratio of a person's weight on the moon to their weight on Earth is 1 to 6. Okay, and if a person weighs 170 pounds on Earth, what is their weight on the moon? Okay, so there's a few pieces to untangle here. Okay, notice that we are given that 1 to 6 here. Okay, and so we're given this 1 to 6, but we got to figure out what that is telling me. We need some units in here. Okay, and make sure you realize the order of a ratio follows the order of the wording. So it says the ratio of a person's weight on the moon. So this is a moon weight right here. Okay, so the ratio we're looking at is moon weight, and then the ratio of a person's weight on the moon to their weight on Earth. Okay, like that. And so that would be what we're used to, the actual weight, or the Earth weight. Okay, like that. And so what we're saying here is that we have 1 pound on the moon to 6 pounds. Oops, sorry. didn't write it the same way. 6 pounds on the Earth. Okay? And if we wanted to write that as a fraction, we would say 1 pound on the moon over 1 pound on Earth. Or 6 pounds on the Earth, sorry. I'm trying to watch what I'm writing. I'm not looking at what I'm writing carefully. Okay? So the key thing is here, if we want to take the units out of it, the key thing is the form of that ratio is moon weight to Earth weight. Okay? And so all we need to do is take what we're given, that's 1 over 6, equal to, now what are we given? We're given the Earth weight. So we need to put that 170 somewhere. Where do we put it? Well, the denominator of these fractions are the Earth weight. And so I put 170 right here. And then we're trying to find the moon weight. Again, you could use X. That's fine to use X or Y. But since we're doing moon weight, again, why don't we use M again? It's funny we have the same letter. Okay. Now, there is a shortcut on this one, but just to follow our usual process, that now we have a proportion. And so here's my first cross product. Here's my second cross product. And so for my first one, I want to equate the cross product. So I have 1 times 70 is 170. And that's equal to then 6 times M. Okay? Like that. And then we can divide both sides by 6. Like that. You might notice that these reduce by 2. I've run out of room, but once again, so I'm going to come up here. I'd probably keep going down if I were working on it at home and on paper. So notice that those reduce by 2, and so we get 85 over 3 is equal to M. Okay, if you want to compute that to a mixed fraction, what is that going to be? That's going to be 28 and 1/3. Okay, and so there's our weight. And now, but we got to remember what it is here. What is that? M. So that's the weight on the moon. Is 28 and 1/3 pounds. Okay. So there, if you had trouble understanding that joke earlier, a person that weighs 170 pounds on Earth, as long as they could afford to go to the moon, their weight's going to decrease way down to 28 and 1/3 pounds. All right. So that's the basics. Let's look at one more example, and that should probably be enough to go on. Okay, so let's look at an example that occasionally pops up in our lives. Say you have a pet and they get some kind of drug. And so the dosage for that pet's drug says to use 3 milligrams for every 8 pounds of weight. Okay? And so let's say your pet weighs 42 pounds, and we're asking how much of the drug should be given. Okay? And so, one thing to point out about this too, some of you could probably do some deducing by relating these two and then figuring out how much to multiply that 3 by to get what you need. And there are ways to do that. Just people often make silly mistakes, and they'll divide whenever they're supposed to multiply, or vice versa. And think about this: you're giving a drug to your pet. Okay, there could be bad consequences for getting that incorrectly. And so that's one thing about algebra, is that it provides you a systematic way to figure out these problems so you can be sure that you're getting things correct. Okay? And so the key thing is here is what, in terms of what we're giving, we're talking about 3 grams for every 8 pounds, right? If you don't know that abbreviation, I use the abbreviation. One thing too, just mathematically to answer questions, you don't even have to know what these units mean. As long as you keep things lined up, you can still answer the questions and just use the units of whatever you're trying to find. So if you see abbreviations you're not familiar with, you can look them up. Just do a Google search. But if not, if you want to just solve the problem, just assume that there are some unknown things, but just keep up with the label. Okay? And so we have this idea of for every, so that kind of implies a fraction right there. If you want to write this as a ratio, that would be 3 milligrams to 8 pounds, which we could then write as a fraction. 3 milligrams, we could say, for every 8 pounds All right, and I'm sorry to keep going back and forth between the abbreviations and the words there. I just realized it was strange that I was using abbreviation here and words there. Okay, so the key thing is here is that we're relating these milligrams or these mg's, if you didn't know what they were, to these pounds or these lbs's. Okay, that sounded funny. All right, like that. And so in terms of what we're given 3/8, and we want to set that equal to something. And we find what else that we were given in the problem. What else were we given? We were given these 42 pounds. So we just got to figure out where to put that 42, okay, in the top or the bottom. But if you had taken the time to write this down, then it can remind you. The 42 is a pounds or an lbs, like that. And that's in the denominator. And so I'd put that 42 in the denominator, okay? And so then in my numerator is what I'm trying to find. I'm trying to find the milligrams or the mg's. And so let's just use X this time. You could use D for dosage if you wanted to, all right? And so now we're ready to do our proportion. And so we have, we need to identify our cross products. Sorry, I was looking at something, starting to work on my calculator already. I started doing too much at once there. Okay, we need to look at our cross products. Thing is, for the one in red, we need to do 42 times 3, right? And that's what I was starting to do on my calculator too early. That's 126. So for my first cross product, I have 126. For my second one, I would have 8x. Okay, like that. And then I would just divide by 8. Like that. All right. And so the 8's cancel. I have 126 divided by 8. Notice that those reduce by 2 at least. And so if I reduce these by 2, that's going to, on my top, it's going to be 63 over 4, like that. Okay, if you want to go and convert that to mixed fraction form, I already got it, but you might take a moment to get that. 15 3/4. Okay, now again, make sure to realize what that is. Is this a number of pounds or is it a number of milligrams? And different ways to find it. How much, the question asks how much of the drug. That has to do with the dosage, so those would be mg's. The other way to get it, to understand, is we found X. X started out in the numerator, and what were my units of my numerator? Those mg's or those milligrams, like that. And so what's the answer to this question is that the dosage is 15 3/4 milligrams. All right? So that's the idea of using proportions to solve problems involving ratios. And then in our next video will be information about how to use this same idea to use unit conversions, where you're not always making silly mistakes by mismultiplying or misdividing. I hope that helps. All the best.